Good afternoon, everyone. Welcome back to another event in the School of Architecture's student-led lecture series. Today we are excited to have Ruth Mandl with us, joining from New York, where she leads a firm called CoAdaptive Architecture with her partner, Bobby Johnston. CoAdaptive is a majority women-owned practice in New York City, and they focus on energy efficiency and climate resiliency. To that note, many of their projects and built work tie into themes of reuse, low carbon, and passive house design standards. So following her lecture, please remember to remain seated as we open the room for Q&A. For now, I'll just hand it off to Ruth. Thank you and welcome.
So, is my mic still working? Can you all hear me? Perfect. Well, thank you, Leland, for the introduction, and thanks for having me. I'm honored to be here, and I'm honored to share some of my work or our work with you who represent the future of this profession. Something that I've always thought is that architects should be doing more as it relates to tackling climate change, and this is something that CoAdaptive thinks a lot about. I'm going to share some recent projects that start tackling some of these issues, but there's always more to do and ways in which we need to turn up that dial and all contribute. Firstly, I do want to say that even though it's just me in front of you here today, CoAdaptive is a team. This is them. And we're a collective. We try really hard to share ideas and listen to everyone's voice because we want to acknowledge that the manifestation of ideas is a collective achievement. And I think the days of the star architect, the sole architect, they're behind us. At the moment, construction processes are relatively linear. When something has reached the end of its usable life or determined usable life, it's discarded, landfills are growing, while resources are being depleted. Construction and demolition debris is estimated to be nearly 1/4 of the national waste stream. Annual C&D is expected to reach 2.2 billion tons globally by 2025. According to the EPA, it has increased by 342% between 1990 and 2018. That's a lot. We tend to think of the things that we throw away as going elsewhere, but the fact of the matter is that we all share a planet, and the junk that we discard here in the developed world disproportionately affects communities that are contributing much less to this problem. Meanwhile, the embodied energy and making materials around the world, mostly steel and concrete, accounts for about 16% of global carbon emissions. Embodied energy includes the entire life cycle of the material, so from extraction of the raw material to the manufacture, transportation, and installation of products at the building site. Cement production, which is a key ingredient of concrete and its most carbon-intensive ingredient, has increased almost 30-fold since 1990. I think our industry is coming around to realizing that operational energy of buildings needs to be reduced. And in some ways, that's the easy part. I think the less recognized, but recently more talked about aspect of our built environment is actually embodied energy of our buildings. It's often assumed that embodied energy of a building is small compared to the energy used over its operating lifetime. However, if you assume, as an example, a house built to normal operating efficiency, the amount of energy needed to build that house equals the amount of energy used in operating it for about 20 years. In other words, if the house lasts 20 years, the total energy consumed is half from building it and half from operating it. The conclusion that we draw from this is that it's essential for us to pay attention to both the embodied and the operational energy in order to have a real impact. We have to design our buildings to operate to zero or as close thereto as we can get. There's no doubt about that. But in doing so, we have to pay attention to how we're achieving that goal. If we create a passive house that operates at 10% of a quote-unquote standard building, but achieves this by packing it with foam and spraying the inside with spray foam, I think we're missing a large part of the point. If you have to wear a hazmat suit to install something, chances are it's not very good for the occupants of the building or for the environment. Foams are petroleum-based, and eliminating the extraction and use of petroleum will be critical in reaching the carbon emission goals, the toxicity of the stuff aside. This is the Union Carbide building on Park Avenue in New York City. It was built in 1961. This steel and concrete building was the tallest building ever to be built by a female architect, Nathalie Deblois, I'm not sure how to pronounce her name, of SOM. In 2011, it was completely renovated to LEED standards. And in 2019, that's only 8 years after its renovation, it became the tallest building in the world to ever be demolished. Norman Foster designed the new 70-story tower, which takes its place. It will be 2.5 million square feet, replacing in its entirety the 1.5 million square feet that were torn down. Treehugger reported that according to a basic carbon calculator, the embodied carbon in the building amounts to 65,000 metric tons, which is equivalent to driving nearly 14,000 cars for a year. And that's roughly the amount of carbon that will be emitted in the next few years building, or has been, it's been under construction, building the first 2,400 square feet. I did read that 80% of the demolished building is being recycled, although I've been trying to find more info on that. Really curious what happened and where those materials went. I'm sure you've all heard of architects Leclerc. These are 2 points from that declaration. One is to upgrade existing buildings for extended use as a more carbon efficient alternative to demolition and new build whenever there is a viable choice. And the other is to include life cycle costing, whole life carbon modeling, and post-occupancy evaluation as part of our basic services to reduce both embodied and operational energy use. So as an industry, we have significant problems to solve. We need to stop depleting resources at a faster rate than we can regenerate them. We need to be aware of the energy that goes into making new materials, some more than others, and we need to curb the mountains of waste that we are adding to yearly, weekly, daily. An article that I read a couple years ago by Rowan Moore for The Guardian, entitled, "Where are the architects who will put the environment first?" really resonated with me. I'm going to read a quote. "Architects are still trained from studenthood to perform in what Steve Tompkins, one of the driving forces behind Architects Declare, calls a competitive and individualistic profession. They get more glory for designing a singular new building than they would if they worked out a good way of insulating old houses. Yet as most of the building stock of the future is already with us, and as demolition and rebuilding entails the chucking away of whatever went into making the original, the latter is likely to be more useful than the former. So what if we start seeing our cities as material mines, as a rich landscape that needs to be adapted to take us into the future, to be resilient to all that it will bring? An interlude of an image we created during the pandemic. We were thinking about all those glass office towers in Manhattan that were sitting mostly unused at the time, and we came up with the idea of a green interstitial space that is both urban farm, serving and feeding the city, and at the same time absorbs the intense solar heat gain that these buildings deal with, thereby reducing their operational energy. Each building within our city, no matter how beautiful or ugly, is a treasure trove of embodied carbon that should be utilized. We can't afford to scrap it all and start over. We need to use our ingenuity to reinvent and reuse and redefine and adapt. And as we do this and we carefully take them apart to fulfill new uses and improve their operational efficiency, we need to be aware of what we're taking out. Where can it go? What useful life does it have left? Maybe another industry can use it, even if it has become useless as a building material. We can then take this a step further and start thinking about demolition and deconstruction when we plan things. Letting go of our egos long enough to understand that nothing is permanent. And what if we start planning for this impermanence and we designed in a way that things can be taken apart into their component pieces? Then maybe instead of this, every time you want to move a wall, we can conceivably plan for the wall to be shifted, to be taken apart and put back together in the new desired spot. So if we start planning for a future adaptation, we can start closing the loop and ultimately reform our linear construction practices into circular ones. So this is a shot through the window of an adaptive reuse project we completed in the summer of 2021. The project sits in a low-lying area of Brooklyn around the Gowanus Canal, which was once a vital cargo transportation hub for Brooklyn. And the area is built up of a network of factory and warehouse buildings that primarily date back to the late 1800s. Recent zoning changes around that canal have meant many new 10-story buildings have been erected. A lot of the old buildings are being torn down. This is our site. It's 100 and 100 and comprised 100 by 100 feet, I should say, and comprised of a quarter of what used to be a compound of 3 connected buildings, which formed the Royal Metal Furniture Company. The building dates to around 1900 and is a single-story masonry exterior with 2 lines of 50 by 100 heavy timber roof trusses, columns, and girders. The building has had 3 previous lives already. Upon the demise of the Royal Metal Furniture Company, it was used for many years as simply warehouse space and storage facilities. And most recently, before our client purchased it, it was small art studios and office space. You can sort of see from these 2 photos it had been compartmentalized over time. Spaces were dark, but you could get these glimpses, these moments of the original building. To our client's huge credit, they were able to see the potential of this building in its current rundown state, and they bought it to convert it to theatrical rehearsal space and studios. They came to us with the desire to create an open, light-filled space that was classic in its clarity and simplicity. His objectives also included the aspiration to understand wayfinding upon entry, which was very counter to the current state of long, winding hallways and labyrinths of rooms. And lastly, he wanted to be authentic to the building's character and inherent qualities. With this, we set out to restore the character of this heavy timber building, exposing and honoring the heavy timber trusses and reinforcing the stubble A-frame while adapting it to meet the new programmatic requirements. To celebrate the wood and masonry character of the building, we chose to insulate it from the exterior. This was a difficult discussion with our client who wanted the masonry to be exposed from both sides, which wasn't possible by energy code or otherwise. But it allowed us to expose the existing material's warmth from the inside and the textures and the history of use. And we even left intact the construction spray paint annotations on the exposed walls, which you can sort of see. Yeah. This decision also reduced the need for interior finishes and significantly reduced the amount of drywall or paint that a project of this size would usually need. So it was both important to retain the building's existing heavy timber classification and to keep the embodied carbon of the new structural work to a minimum. And so we decided to use mass timber for the required structural insertions. So CLT slabs and glulam beams and columns sourced from sustainably forested vendors within North America were installed in one half of the building. The material allowed for large column spans and an open layout that worked well with the programmatic requirements. Also, it allowed the heavy timber trusses to remain unaltered and exposed. To our knowledge, this project represents the first use of CLT on a fully commercial adaptive reuse building in New York. This did present some hurdles, including the fact that the GC had never worked with this material before, and we were installing it in an existing building with the existing roof and trusses to remain in place, which meant we couldn't just pancake the slabs, but instead used the existing timber to support a gantry crane, and then we slid the CLT slabs into place through an existing opening in the masonry on the side lot. The CLT panels then fit like puzzle pieces within the existing building and were scribed to the irregularities of the brick walls. One benefit of using CLT in an existing structure is that it was protected from the elements from the get-go, and it was also relatively quick to install. They managed to install about 2 to 3 panels in a day, which meant the entire new floor was installed within a week. Here is a view of the Bleacher Staircase. You can read the CLT slab in the edge above the newly inserted glulam beams around the opening, which we purposely exposed in detailing the glass railing, and 2 new skylights, which were inserted above the space to bring natural light deep into the heart of the building. This bleacher space connects 4 rehearsal studios and serves as sort of the market square of the building, hopefully fostering unintended conversations and creative collisions. I've had the pleasure of going back to the building since it's been in use over the last year, and it's been the most fun to me to sort of see that the way that this space was intended to be used is actually how the artists are using it. So there's people lying on bleachers, working, having conversations. It's really great to see it active like that. This is a detail shot of the edge of that Bleacher Staircase. We really wanted the CLT buildup to read clearly as you descend into the lower level. And you can also read the acoustic sandwich, underlayment, 3 layers of plywood, and then the finished floor, which ensures that there is no acoustic transfer between the floors. I will say that working with wood and working with CLT allowed us to make this sandwich a lot less deep. If we had worked with concrete or steel, it would have been a deeper sandwich because wood has very good acoustic properties from the get-go. So the building's existing material palette becomes a very primary part of the interior. In addition to the trusses, which we left exposed in their original finish, we carefully salvaged the existing industrial doors to be used within the existing layout. The orange door that you see in this picture was hung from a new track and separates the administrative offices from the main entry and circulation space. So the existing structural lumber that was removed in creating our double height space and inserting our CLT atrium floor slab was carefully removed and stacked for reuse. All the structural lumber in the building is Longleaf Pine. This is a tree that once covered 90 million acres of the US from southeastern Virginia to eastern Texas. And some of these trees were 3 centuries old when they were cut down. They're dense, durable, and saturated with resin that makes them unusually resistant to rot and insects. And in the decades before steel became the material to dominate, Longleaf pine was the strongest building material around. And then now the only way to find this original strength longleaf pine is in precisely this type of building, a manufacturing building built around the turn of the century in the big East Coast cities. And unfortunately, the clear cutting of these vast southern forests in the late 1800s wiped out the entire range of original growth hard pine. So today, this material is really a rare sunken treasure. And I have to say, I didn't know this when we first started working on the building, but sort of learning about the history of this tree and these forests gave me a new love for the material. So we reused this wood in our project, both in the wood posts that surround the bleacher opening to divide up the acoustic paneling in the main assembly space. Everything was cut down in place, and then existing finishes were flaked off, but largely retained and encapsulated in a matte clear coat to avoid any lead paint flakes or anything like that. Here they are installed in the main space. And if you think about all the carbon that's stored in these old logs, keeping them on site was really the best thing we could do to both honor these old trees and to ensure that the stored carbon remains in the built environment for another decade or beyond. And all the wood that we were not able to salvage within our project was picked up by Sawkill, who are a wood flooring and paneling company located in Brooklyn, and they specialize in reintroducing locally sourced reclaimed wood. So it's probably on people's floors now, on people's walls. Here's another image of the completed assembly space. You can read the existing heavy timber trusses and the roof joists alongside the reintroduced joists above the mirrors on the right-hand side. We opened up all of the existing masonry openings that had previously been enclosed over the life of the building, and we repaired the existing clear story along the ridge of the roof. So all of that natural light flooding into a building was sort of there. It was just hidden. This is the same view on the other side, overlooking the new Bleacher Stair. You can see a projector and screen that will be used for screenings. And we really felt that our job with this project was about celebrating and unearthing the beauty that was already inherently present in this building. Since the building is located near the Gowanus Canal, which is a low-lying area of Brooklyn, the owner wanted to be prepared for big flood events. The wood floor in the big assembly space, which sits about 10 feet below the street level, is made up of demountable panels that are each 3 by 6 feet. And so in the case of a flood event, these panels can be pulled up and stored at a higher level, meaning that the water can come in and recede without doing damage to the finished sprung wood dance floor. Since the space was used for dancing, jumping, and performances, it was important for the floor to be a proper dance floor. And we did a lot of research at the time into demountable options that could be purchased. But it turned out that most of them came with a vinyl finish that would have hid all the fastenings. And the owner really wanted the floor to be wood and to have a seamless wooden finish. And so we collaborated with a local set building shop in New York to custom fabricate them. And in the end, you can't tell that these panels are demountable. It looks like a seamless floor. So this project starts touching upon some of the elements that I talked about early on. It introduces elements of circularity in the reuse of the building, in the reuse of the materials, and in the use of carbon storing CLT and glulam instead of carbon-intensive steel and concrete. It's also starting to think about demountability in the context of resilience and reuse rather than waste. But to us, it's only starting to hint at the possibilities here. A professor of mine always used to say, turn it up to 11. So yeah, we got to turn these concepts up. In this context, we can't help but wonder what the future of the building holds in its fourth iteration and its fifth iteration, and how it will be adapted when it changes ownership again. There's another quote by Joan Mark Simon, the director of Zero Waste Europe, that really resonated with me. There are no such things as sustainable products or foods. There are only sustainable systems. In nature, the sustainability of ecosystems is not related to the qualities of the parts, but rather to how they interact with each other as a whole. So I feel like as designers, we need to start focusing on the broader systems that we're designing within. The journey that our resources make matter. And the only way to reach sustainability or regenerative design is by closing the loop on our linear practices. So once you start thinking in loops rather than lines, I think you can really apply that at all sorts of levels, layers and scales. To begin with, there's really two fundamental material cycles. There's the biological, which stores carbon and has the ability to return back to Earth, providing compost and nurturing the soil. And then there are resources such as stone and metals, the human-made composites such as glass and steel. And these are made from finite resources that use significant amounts of energy to make. And I think we need to respect these and work with their ability to last and to be reused. They should never land in our waste streams. Plastics are a whole other category that I find hard to contend with. They're too toxic to ever be fully circular. So these cycles and loops of productions exist at several scales. At the building level, there's a loop that we already touched upon. Building components are designed for disassembly, and components are sent back to manufacturers for reintegration into their assembly lines. And distance and travel ends up becoming a relevant component when we start thinking in circles. And as such, condensing them becomes important. So thinking in hyper-local circle with the idea that one company's excess or one company's waste becomes another company's ingredient. So CoAdaptive actually launched this year a construction management arm, CoAdaptive Building. And our desire to start an architectural-led design and build practice is in large part informed by the fact that we want to have a more direct impact on the material waste streams for the projects that we're renovating, so that we're prioritizing careful deconstruction rather than demolition to ensure that whatever is removed is either reused or sorted for down or upcycling. As mentioned before, reusing as much of the existing building in situ is the best way to keep all that carbon locked into the built environment and to not generate waste. But much of what does need to come out probably still has usable life in it. One person's trash is very often another person's treasure. So we have all these items picked up by partners and donated for reuse. A great perk of this is that there's tax deductions to property owners and those often offset the additional cost of deconstruction over demolition and actually often save money for them. The materials that are removed when upgrading and renovating a building can either be upcycled, like the image on the left, which is what we did in our adaptive reuse theater. So maybe larger wood members can become new architectural features. And smaller elements can be separated by type and be downcycled for a new use. The parts on the right that were collected in this dumpster are going to be ground down and be used in new gypsum wallboard products. So we recently made a sign for one of our projects undergoing deconstruction to explain to passersby maybe what's different about this project, what's different about the process of deconstruction rather than demolition, in the hope that it catches on. So when we retrofit existing buildings to be passive houses, we're very conscious about what we add back in. Insulation is one of the materials that we use significant amounts of in high-performance retrofits. And so it should be natural, it should be breathable, and it has the opportunity to similarly be a carbon sink. We're big fans of wood fiberboard insulation, which we have traditionally needed to import from Europe. But we're super excited. There's a company called Timber HP that's going to be opening a local wood fiberboard insulation plant in Maine. And so wood fiberboard insulation comes from the waste product of the wood industry. And all the properties that make wood a fantastic material generally also make it great for insulation. It's superior to foam of all kinds because it's breathable, it can handle moisture, and there's the health of making it and what happens to it at the end of its usable life. At CoAdaptive, we signed a pledge, or we made an internal pledge in 2019 to avoid foam of any kind at all cost. So we want to consider the materials that we specify for our projects very carefully to work towards this idea of circularity. And any new materials we do use, we're constantly researching into new low-carbon alternatives to the current status quo. One thing we're really excited about is the use of hemp and hempcrete for exterior walls. They're created from a completely natural mix of hemp and lime and water, and they provide insulation rates up to R70. But by themselves, unlike concrete timber blocks, they're not structural. They work with an internal post and beam system. But unlike concrete blocks, they are carbon sinks and they're vapor open, which allows moisture transfer between walls and through walls. And that way we can control humidity and temperature better. This is particularly good when paired with passive house principles. They're also fire resistant and acoustically absorptive. Cork is another one of these materials that we're really excited to use. We're currently working with it on an enlargement of an existing retrofit where we're using it at both the insulation and the exterior cladding. It's extremely waterproof and erosion resistant. It also has beautiful aesthetic qualities over time. Cork is harvested from trees without harming them. which makes it naturally regenerative. It's harvested by stripping the outer layer of the skin of the tree, which then regrows over time for the next harvest. And in the factory, the cork is shredded and compressed at high temperature, which causes it to expand and the natural saps to melt, which bind it together as a glue. And then once it's cooled, it's ready to cut and measure. So we feel like an increased demand in cork would mean we would have to plant more trees, and that could only be good. So the next evolution for us at CoAdaptive is to start thinking about disassembly. So for designing for things in such a way that component pieces can come apart and be reconfigured if required. We're working on a panelized wall system at the moment, which we're prototyping and building out in our new office space. The system relies on a wood frame and then easily mountable inserts that are made from wood and wood fiber board. There are no adhered components, so everything can be disassembled into its component pieces. And the modules are about 1 meter by 1 meter, which means they can be carried by 1 to 2 people, which is really important for an adaptable retrofit solution. And then we're layering them, as I said, from wood and natural insulation and with glass inserts as needed so that they become versatile with the material that you adhere. These are some renderings of our new space in the Brooklyn Navy Yard, where we're building out a wood shop. In that wood shop, we'll be prototyping those panels and showcasing them in our space. So if we start moving towards a circular system, we can conceptualize borrowing man-made materials rather than owning them outright. So our metaphor as the city as a mine really becomes one of a material library. If manufacturers are held to be accountable for the entire life cycle of their products, it would increase maintenance and quality of products, and it could change economics of ownership and lead to more access and affordability in construction. So as you can maybe tell, we're passionate about this, but we're ourselves always on the path of discovery. So I'm curious to hear your thoughts and your comments. I think as the next generation of architects, it is your job to interrogate the status quo and to make it your mission to hold the older generations accountable. So thank you for having me.
So thanks to Ruth for the lecture. We can now open it to Q&A if anyone has a question. Or I can go first.
I looked at your images of the system that you're talking about using, and it's interesting because it reminded me directly of Walter Gropius's 2 houses for the 1927 building exhibition in Stuttgart. Sadly, they didn't survive. Apparently, they got hit by a bomb during the war. Uh-oh. But the rest of the buildings from that building exhibition are still there. But they were made out of fiber with wooden frames, and they had visible joints all over. And it's interesting. It's difficult to find information about them, and they're not there anymore. But they use the same kind of compressed fiber for the outside and the same kind of wood frame. And the wood frame was visible everywhere, which was very different from the pure white forms that were so common in 1927 among modernists. But
interesting.
Yeah,
I will check that out. Thank you.
So my question is, since your firm is in New York, I was wondering, would your firm or missions be different if you were in a different place Obviously, New York is sort of this material mine in itself, and maybe if you were in somewhere else, how would that change how you practiced?
Yeah, I think that's a great question. I feel like I've spent my whole life living in cities. I was born in Vienna, and then I lived in London for a while, and now I live in New York, and it's always these big, dense places, and I have admittedly never lived in a place that isn't. So I think my work is very much informed by that. I think my answer is I don't know. I'm sure it would change. I'm sure it would change.
So my question is, so you were talking about how you're considering a system that can be deconstructed. Would that system, wouldn't it also help with like maintenance? So what is your opinion on maintainable building and how that can affect, like how can you design your building to be maintained?
Yeah, I mean, I think in an ideal world, something breaks in one part of that wall, and instead of sort of having to take it apart, make a hole to maybe access what's behind, looking for leaks, or who knows, you can take a component part out, and maybe that part needs fixing. Maybe two neighbors need fixing. Maybe the plumbing behind it needs fixing. But hopefully it alleviates some of the waste that's generated when we need to, take an entire thing apart to access systems behind it. And we have also thought about the circularity of this. Maybe maybe the gaskets are faulty on one block and it goes back, it gets fixed. Maybe certain component parts need to be replaced, but not the entire thing, and then it can be reused.
So you mentioned a few materials that better contribute to a building that can be part of a circular material economy. My question would be, with these materials being harder to access generally because traditionally there's a lower demand, and so with hemp products and some of these things, they're probably growing in how common they are, but maybe aren't as common as other materials. What role is there in the architect in making these more available? Because we aren't farmers or people in that sort of production side of the economy. What role do we have in having these materials be more available to us as designers?
Yeah, I think that's a great question. We actually ran into exactly this problem with a recent project where we have to insulate the roof. And so we're trying to source foam glass, which it does not have foam in it, contrary to the name, but it's sort of compacted mineral and glass. And the lead time on that material is 6 months. And we asked two of the vendors that carry it why they don't have any in stock. And according to them, it's because nobody is specifying it. And so as architects, we have that power. We can specify it, and if more people specify these materials, then manufacturers will catch on and make them more available. I think the other example is this wood fiber board. So this company that's launching a local manufacturing of that material is making a real effort to hit the market at a price point where it can compete with foam. And I think that's important, because if it's always the more expensive option, that's not great. Then it's only available to some. And so I'm excited about it actually competing with the foams and becoming a go-to.
Thank you.
Going with the metaphor of mining the city, I'm assuming you kind of build this catalog of parts and materials. Is that something that you build and develop per project, or is it just growing in the background of the firm that you can go back to every time you get a project?
Yeah, that's a great question. So one of the reasons we moved to our bigger space in April of this year was, one, because we wanted to have a wood shop and start prototyping things ourselves, but two, to also have a place to store things so that if we really like something that's coming out of one project, we sort of can hold on to it for a while and reintroduce it somewhere else. That said, we're small and there is tons, tons and tons of stuff to salvage. I was reading about a company in Germany, actually, that this is sort of, they've created a marketplace for materials, for building materials. So they 3D scan them, point cloud scan them, and then there's an online marketplace for it. There's also a company in San Francisco that does something similar, where they try to find homes for the materials before a building is demolished, so that it can directly go. But I think that there's a gap there that needs to be filled. We can't do it on our own. That's for sure.
About sourcing materials, how do you keep your finger on the pulse of maybe what's coming next or what's available to you? And then how does your relationship with the contractors, since they might not be as widely used or as familiar with, how do you have that kind of relationship with your contractors with the new materials and the new processes for building?
Yeah, that's a great question. I think the first part of that question is research. We are trying to constantly do research. There's also great resources like the Parsons Healthy Material Lab. They're doing amazing things to make those resources available and to give data on all of the things. And then on the contracting front, I think that's a constant struggle, to be perfectly honest. People want to do things the way that they've always done things, and it's easier for them, it's less effort. And as architects, as much as we write it into our project manuals, as much as it's baked into our sets, that does not guarantee that it will be used. So it takes a lot of diligence during construction administration to make sure that they're ordering the things that we specified, they're ordering the no formaldehyde plywood, and they're using the no VOC paints. And I think it's also one of the reasons, the material waste stream reason aside, that we want it to be design build, because then we can do the ordering ourselves and we can have more control over that. It's frustrating. It's an uphill battle, I'm not going to lie. I love your question. I mean, for me, from personal experience, I had some amazing professors. I took a course that was about the sustainability of cities. I can't exactly remember the title of the course, but I took it at the same time where I was also doing a space studio. And so reflecting on everything that Earth provides for us, having to design an outer space, and then at the same time taking a class that talked all about the history of urbanization and sort of how civilization came about. For me, I think that happened in my second year of my master's studies. It was sort of this aha moment where I was like, we have only this one planet. Maybe we can all ship off to some far distant place, but for the time being, this is all we have. I don't know how we can implement that in. I think it's just exposure to some of the problems that we've created, knowing that they're there and not ignoring them. I'm not sure. It's a great question, though. Okay.
Thank you, first of all, for showing us sustainability in a way that makes architecture. Many times we have seen contraptions that get stuck in under the premise of sustainability. I really enjoyed that very much. I have one very specific question about the CLT floor. What is your span that you achieve with the CLT part? And then the layer in between separates the upper layer from the CLT part, which is plywood. Was that plywood connected together to add as a structural part in the middle centers of the floor, or was it just laid on top?
So the plywood, actually, even though you read the edge of it as a solid, let me see. Yeah, even though you read that solid edge, there's actually voids, and then there's some sprung, so that it's like a bouncy system. So it's not solid all the way through, no. But it reads solid at that edge.
What is the layer that separates?
Oh, it is a recycled rubber mat. Yes, it is plastic. We actually looked at using cork for that. I can't remember the reason why we didn't go cork. But I asked this question at a talk a couple of weeks ago. I have this fundamental question of, we have all this plastic around us. We know that it's not healthy, and we don't want to build with it, but at the same time, we don't want to just stack it up. It's never going to rot. So what do we do with it? This particular material was made from recycled rubber that comes from old tires. There's lots of those. But it does off-gas, and it's still not, it's not great.
How far did you stand? How far did you stand?
Oh, that was your other question, right. I think it's 40 feet. So this is a 5-ply CLT floor, which you can sort of read, and then it's our acoustic underlayment, that rubber floor, and then it's a sprung wood floor, so it's the plywood, and then the finished floor on top. And the depth, I don't know. I think it's about a foot, a little bit more maybe, 13 inches.
To add on to that, I think CLT is really, really cool. So from your experience working with it, what were some limitations or things that hindered or helped the design when you guys were working with CLT?
I mean, like I sort of alluded to, the building was a heavy timber structure, and so we were able to file under the heavy timber code, which means that all of the wood could remain exposed. And so our CLT has a 3-hour fire rating. And it meant that we didn't have to cover anything in sheetrock, and all the existing heavy timber and the new heavy timber could remain exposed. The other thing that we looked at was sort of acoustically, what would our floor sandwich need to be if we built this up from steel? What would it be if we made this concrete? And it provided the thinnest possible assembly from those. So that was another reason why it was picked. And then lastly, but maybe not lastly, but one of the important other aspects is sort of the biophilic aspect. Now when you're on that lower level looking up, you're surrounded by the warmth of the wood, which is a very different feeling than if that had been a sheetrock ceiling. And it also meant all of the systems, like that slab cannot be penetrated in any way. So all of our systems had to be below. So there was a lot of work that went into sort of routing our electrical lines and our HVAC and sort of being very honest about all of those systems and having them be exposed, which I think went really well with what the client came to us with as sort of a wish list item. I want to be as honest as possible to the materials and the systems that are in the building. I think.
Also, to add on, the dance floor that you guys made, is that also CLT? And if so, or I'll let you answer that, sorry.
No, that is not CLT.
Okay.
That was sort of built up from wood and plywood, and then the finished floor, so the demountable panels. And I think there's something we learned from this demountable system, which is that, unfortunately, each one of these panels is individually labeled, and it has to go back where it started. So you can only demount it from one corner, and you have to demount them all in sequence, and then you have to put them all back in sequence just because of how the finished floor is layered on top. And I think it taught us for our next demountable wall system that I think what's helpful to have is the frame so that each panel can then be same, and the frame offers that guideline. Yeah.
Howdy. So I'm an Air Force civil engineer, and at my last base, one of my jobs was to put together renovation projects for the base. On any given year, we'd have 20 to 30 needed renovations we'd identify, but only get the project funding for maybe 5 of them. So for me, a major concern has always been the cost of these projects, aside from meeting minimum, federally mandated sustainability requirements. So how does the cost of doing these kind of recycling renovations compare with just pulling stuff out, throwing it away, and getting in new stuff?
That's a great question. And I think the answer, unfortunately, at the moment is that it's more expensive. But I think that there's a cost that we're paying that it's not currently being taken account anywhere. If there was such a thing as a carbon tax or a monetary value to the waste we create elsewhere, that would even out that equation that unfortunately is still imbalanced. And I think that's actually one of the biggest things, one of the biggest hurdles in making it less expensive and becoming a solution that's more widely adopted. Because yes, at the moment, it's much easier to tear something down and start over because it's cheaper and because it's easier. And yeah, I think there's things we need to do at the policy level to maybe change that equation monetarily.
So what is the limiting cost, like in following on that question, what is the limiting cost factor
I don't know if it's one thing. It's everything combined. You know, this building, the roof was starting to fail. There was water coming in. The brick was deteriorated, so there was areas where we had to carefully remove and reinstate and refinish. And one of the other interesting things is that because this building was part of this bigger metal foundry, all of the plumbing systems, the sprinkler system, the roof drainage, it was all tied together with the neighboring buildings that were now under separate ownership. So part of this project was also to sort of peel everything apart and give this a new sort of soul identity, to peel it apart from the systems of its neighbors. So all those things, yeah, so instead of, I think if you also, yeah, I don't know what makes it more expensive. It's sort of all those things. You're working with something that isn't plumb, it's not straight, so it's not as easy as just.
Are there any other questions?
Yes, it is a metal facade, and it's a new roof, although a lot of the sheathing, the existing sheathing, was remained intact. I don't think I have any images of it, but in the upper floors, it's kind of nice because you can see where sheathing was replaced and where old sheathing was remained, and you can sort of read that patchwork. And then we insulated from above and applied a new membrane. The windows are all high-performance, triple-paned windows, which was also important from an acoustic perspective, not just for sound coming into the building, but also for sound leaving and not disturbing the neighbors when there's a big performance. So in this case, it sort of had two great repercussions. One was the sound, and one was the operational efficiency of the building. Yeah. I think.
Last call.
This is an exterior shot. No. Yeah, to your point, we haven't had to do new foundations very much. We usually work with what's there. It's one of those tricky things. But I'm not against concrete per se. I feel like it's one of those things that will last a really long time. I think it's just about respecting that and then extending its usable life for as long as we possibly can when we do use it.
Okay, so I'd like to thank Ruth once again for coming. I think it was a really good discussion period, so thanks for sharing your thoughts with us today, and we'll see you next week for our last lecture.
a degree in like sustainability. Okay. You will be sought after. Because I talked to my professor about it, and he was more like, well, when we like, we're all talking about building, and he was like, well, I think just focus on something else, or like focus on one specific thing. Because then he was like kind of pointing out that sustainability is like an industrial area. Okay, well, I was just wondering because I know you said earlier you had a master's in building. Oh, my master's in architecture. Okay. Yeah. Okay, so your sustainability like came from that. Yeah, I think it was always sort of a passion of mine, and then I picked the courses and the classes, professors that had that. Thank you so much.
Hi, I'm Devanshi.
Nice to meet you. So we were talking about the hemp plant. So you said that it's not a structural material to build. So like I know there are a lot of places that experiment with hemp, right? So do you think if it's like there's a possibility in the future that it can replace concrete and can go as high as concrete can go? Like right now there's a limitation. Like how up above it can go? Like we can use the hemp
I
plants.
think it would be combined with like the system. I don't think it ever, unless they mix it with something that is structural itself. But at the moment, you work with like a full system.
Yeah, so that means we can go.
But
as
it's
high
not
as
a
we want,
structural
right?
itself, is it?
No, it's not structural itself.
But with the force, like we can go as high as we want, right? With hemp blocks
Yeah, I
or
feel like
is
you
it-
almost use the secondary structural
Yeah.
material and you use it as your all system. Yeah. I'm not an expert on the subject myself.
Okay.
I'm just very interested.
Yeah.
So tell me what you found out.
Sure.
I missed the beginning of the lecture. I was a little bit late. I was wondering, like, where did you study and, like, what was your focus? Like, was it just sustainability or was
No, I never did anything focused on sustainability. My undergraduate degree was in interior design, and the course had a heavy focus on adaptive reuse, so really sustainability. And then I worked for 2 years, and then I did my master's in Columbia in New York City, and I was studying for a year. I sort of picked my professors and picked the classes that were interests, and then I picked sort of a sustainability pathway, but I
because I'm kind of like interested in sustainability, but like more towards energy-based designs, like passive designs. And yeah, I'm like trying to navigate that right now, like what to take, what not to take. So I was just interested. Thank you for your lecture. Have a nice day.
Hi. I really enjoyed the lecture. I'm an exchange student from Germany, and I'm looking for like internships in the US, and I don't know if I will apply. Yeah. So actually, if you go to our website, and then on the studios page, there's like an application button where you can submit. But give me your name so that when it comes in, then I know what it's you. Can I write? When are you looking for? Actually, in February. It's a bit, yeah. Cool. I don't have a lot of time. Well, reach out. Yeah. I'll be back in the office next week. Okay. Thank you. Have a nice day. Nice to meet you. Bye.
It's so sweet. Oh my god, no, he's the only thing that's like made this powerful. Yeah, yeah, and he's like, yeah, but I feel like he's really taking it. So I really did this straight. I think like his wife's come back.